Good afternoon, everybody. It's Monday, the 6th of April, and it's day 11 of Lockdown Bioinformatics. So, I think, as I mentioned on Friday, I'm on leave this week, so I'm having the strangest stay-at-home holiday ever. But I wanted to make time in my life to keep this going, so I don't want to let the momentum slip now that we seem to have something moving. So afternoon, everybody, and we'll get shifting. So what I want to do today is carry on talking about scripting in Bash, which is what we were working with the last couple of days of last week, and specifically today, I want to talk about loops. So I want to talk about making kind of repeating statements in a script that will run again and again for various inputs. This can be very helpful in lots of ways, and I'll try and illustrate at least one of those before the end of today. So first we'll have a brief recap on what we've talked about with scripting so far, and then we'll move on to talk about for loops before we get to the end of the hour. So, okay. Let's begin by bringing up my VM. So my VM's still running. It's had a couple of reboots over the weekend, so I've been trying to help some people get themselves set up. And get as many questions answered on. There's been a lot of kind of questions that I've had on the comments on YouTube and so on. And just wanted to make sure that I've got those questions answered, particularly answered in the comments, so that the answer is there for anybody else coming in to kind of follow things along behind us doing it live, which I know some people are. So I think for most of the issues that have cropped up for people in the first couple of weeks, we've got some sort of suggested solution for those issues either in the comments on YouTube, mostly in the comments on YouTube, so that if you're stuck on a particular lesson, hopefully there are some helpful notes there in the comments. Okay, so scripting. The first thing that I'm going to do before looking at sort of reviewing what we did last week, I'm just going to make a new directory for this week's content. So I'm going to you'll see my present working directory is currently share week 2. So I'm going to go up a level and then make a new directory for week 3 to join my week 1 and week 2 directories. So we'll work on our new things in there. So what I'm going to do is, for the moment, is go back into week 2, just because we're just reviewing the very end of what we did last week. So on Friday we were looking at variables and arguments in scripts. So we looked at the notation for defining variables and making use of those within our scripts as well. And then we looked at arguments, which let us use particular special variables for making use of arguments that we can pass to scripts, so that we can configure our scripts from the outside. So we were looking at the 2 scripts that we wrote at the end of the week on Friday. We had test variables, which is showing the use of defining and reusing variables within a script. So here we're defining 2 variables at the top of the script, var and sleep, and then using those variables after that in those echo and sleep statements. So reusing the var variable to echo it back out to us, and using the sleep variable as the amount of time that we want our script to sleep for. So that was quite simple use of variables, but let us define the concepts and make sure that we know what it is that we're dealing with here, and how we can use variables in scripts effectively. So that's the beginning of that. And then we went on to look at arguments. So arguments are the things that we pass to our script at the command line alongside the name of the script. When we invoke the script, we also pass in the arguments, and they're available to us within the script as special these special variables which have numbers for their names. So we have in the example in this script, we've written a script that takes two arguments. We expect one of those arguments to be a string, which we echo back to ourselves, and we expect one of them to be a number which we use to define the amount of time that we sleep for, and we reuse those variables, those arguments, as variables in the script down here. So where we echo $1 and sleep for $2, that's reusing those arguments. It's worth noting at this point that we do nothing within this script to sanity check those inputs. So we expend no effort at all here checking that the arguments that have been passed into the script are actually usable by the commands that we want to use them with. So echo is one thing. Echo will give you back whatever you pass to it. So echo is less of an issue, I think, here. But sleep expects a number, and if our second argument isn't a number, sleep will almost certainly fail in some way. It will fail because the argument isn't what it's expecting. Now, if we were good kind of well-behaved programmers, we would write some logic into this script to figure out that the arguments that have been passed to it are the right type of thing, so that the argument that we're passing to sleep is actually a number. And if that wasn't the case, then we would have some sort of warning. We'd stop the execution of the script and have some sort of warning that says, well, you've not given me the right inputs here, and you need to give me something different. At the moment, we don't have the tools in our arsenal to be able to do that. So we've not learned how to write a conditional statement, for instance, yet. And so it's kind of, at the moment, it's beyond us to be able to do that. But because this is a little script written entirely for our purposes, for our own use, it doesn't matter too much. We just need to know that second argument has to be a number. But if we were writing this for somebody else to use, or for some sort of distribution, then I think we would have to be a bit better about making sure that we were paying attention to what those arguments are meant to be, and writing some code that would allow us to process those arguments more robustly. But we're not going to worry too much about that right now. It's just kind of pointing out that would be good practice, and that would probably be a good idea. The other thing to point out about this script is the other couple of special variables, the arguments we have passed to this script, excluding the name of the script. So it's saying, okay, in this case, if we ran this as the way that we expect, then we've received 2 arguments, and we're getting the script to print that back out to us, and we're also printing out a list of arguments. So we're getting it to print out the contents of our arguments, and we do that with this $at variable, which will be useful later on, and we'll come to that shortly. Okay, so that's a script that takes arguments, and and also, I mean, he's also using some variables as well. And obviously, the processing of arguments within a script requires us to kind of understand the way that variables work. Okay, so I'm going to exit Nano, and I'm going to take a copy of that script, just because I don't want to have to fiddle around with pasting in hash characters, and it's good to have a kind of starting point. So I'm going to copy my test argument script into my week 3 directory, and we'll start to look at we'll begin our look at loops and at for loops. Okay, so let's take a copy. So cp test arguments to so not into this directory, into our new week 3 directory, which is one level above where we currently are. So // week 3, and we're going to call it something different when we copy it. So we'll call it test loops.sh. Okay, just so so that the name makes sense to us for what we're doing, and then we'll edit it and change what it does, and we'll start to use some loops. Okay, so I'll make that copy, and then I'm going to cd out of my week 2 directory and into my week 3 directory. So there we go. So let's go into week 3 there, and we'll see that file that we just copied, so that's a copy of my test arguments script, and we can look at the contents of it to prove that, but we'll edit this and turn it into a script that contains a loop. Okay, so that's our setup for what we're going to do this afternoon. Okay, so at this point I'm gonna sidestep slightly and talk a little bit about loops and what they are, and why we use them in scripting and in programming. So let's hop across, find my pointer. There we go. Right. Okay. Right. Okay. So for loops, particularly in Bash. So loops are a common what's called a flow control structure in programming. So I mentioned last week the features of what are called Turing complete programming languages, and these are programming languages that are capable of accomplishing any computational task that you set them, which is true of almost all programming languages, certainly all mainstream programming languages. And one of the things that's required for a Turing complete programming language is conditional repetition. So the ability to do things over and over and over again, but changing the behavior of that repetition when required. And loops is a key part of that conditional repetition. And so all programming languages have a way of defining loops within code, and Bash is no exception to that. And the loop structure that the flow control structure we're going to learn today in Bash is called a for loop. So that is where you define each iteration with a for statement. So for A in B, do X, essentially. Okay, let's have a look at the syntax of the statement first. So there's my whiteboard. And there's Jacob's picture of the day. We're digging a pond, so Jacob's drawn me a pond, which is excellent. I mentioned on Twitter that I've spent the day digging a big hole. I suspect I'm going to wake up and not be able to move tomorrow because I've dug about a 2 metre by 1 metre foot deep hole in my garden, and that's going to cause me pain tomorrow, I suspect. But that's the inspiration for Jacob's picture of the day today. So let's have a look at the for loop in Bash. See if this is going to work. Hey, look at that straight away. Right, for. So as the name suggests, a for loop begins with the word for. Okay, so this is a keyword in Bash that says we're going to write a for loop, and the way that what you then do is you then define a variable name. So this variable is going to occur throughout your loop. So it's a variable which you can reference within your loop, and for each iteration of your loop, it will in theory change its value. Okay, so for by convention you would use I, and then in a list of some stuff. So it could be a list of strings, or it could be a list of numbers. It could be almost anything. So for I in A, B, C, D, then in Bash you then say do. Okay, so for A in B, do X. So maybe we can echo our variable. Okay, so we've got our dollars variable, $I. So this is referencing that variable that we've created in our for loop definition. And then the final thing that you have to do is finish your for loop. So tell Bash where the code of your loop finishes, and you do that with another keyword which is done. Okay, so what this syntax does is you set up your loop. So you set up your looping system here in this first block. So this says for A and B effectively. So for sorry, bear with me. There we go. Right. So this is your variable that you create, that we refer back to, and then these things here are the values that variable takes with each iteration of the loop. Okay, so in this case, if you've got 4 things separated by spaces there, this loop is going to go round 4 times. So 1, 2, 3, 4. Okay. So then for each of those 4 iterations, the code between do and done is going to be executed. So this statement, which is the code between do and done, will be run 4 times, once for each iteration of the loop. So the first time, our variable $I will take the first value in the list. So it will take the value A. So when we do our echo here, we will echo out A to our standard output. And that's all that our loop will do in this case. You could put more lines of code between your do and your done statement, and do more things with your variable, but in this case we're just doing that one thing. So that occurs, and then our loop we get to our done statement, and the loop goes back round and sees if there's any more things to execute with, and we've got another variable still there, so it will the loop will spool round again, and this time we will echo the second value in our list, so we will echo B. Okay, so the second time round we will get B printed out to standard output. The third time round, so you get to the done and it goes around again, goes back round and runs again, and this time we'll get C, and then the fourth time we'll get D, and then we have no more input left. So this time our loop will terminate, and then any more code that we want to write afterwards down here, so any more lines of code that we want to write, will all now be executed after our loop has finished going round and round and round. So it's a relatively simple statement for introducing some repetition into our scripts. So from being able to do that conditional repetition that we were talking about before, where we're going to repeat the same structure of code multiple times, but each time that we repeat that code structure, something will be very slightly different. So in this case, we've got a variable that changes its value each time we go round the loop one time. So that's the principle of a for loop, and I'm just going to write this exact for loop in our script to give us that example. Okay, so we're going to go back to our terminal, and we're going to edit our test loops script. So we're going to use nano to edit our test loops script and change it to incorporate this for loop. So at this point, I'm going to delete some of the stuff that's inside here. So if you want to delete a line of text, it's down in the instructions down at the bottom of nano here, this Control K, which it says cut text, that actually removes a line of text from your script, from your file. So I'm going to use Control K to delete some of the contents of this script. So I'm going to get rid of, pretty much everything here. In fact, I am going to get rid of everything apart from the shebang line. But it was that I was wanting to keep anyway, because that's the thing that's slightly awkward for me to type. Okay, so here we go. We're going to put in a comment there, and we're going to say this is an example loop. And exactly as I wrote on the previous screen, I'm going to type the same code in here. So for I in A, B, C, D, 2, 3, 4, do. So a little bit of indenting here really helps you keep your code organized. So this getting into the habit of putting these indents into your code when you're doing some kind of control structure, so a loop or a conditional, can really help you read your code when you come back to it later. So this is good practice for writing readable code. So it's always the case that code is more readable if you have more white space in it. So indenting, things like having these empty lines between things makes your code more readable when you come back to it later. So it's always a useful thing to be able to do. So all we're going to do is echo our loop variable back to ourselves. So that $i, which we're setting with each iteration of our loop up in the definition up here, we'll just echo that back to us each time. And then we're done. That's the end of our loop. And then just to prove that we can do something after the loop has finished, we're going to have an extra echo afterwards, and we're just going to echo hello world at the end. Okay, so that's a very simple loop, the same loop that I drew out on the other screen. So when we run this, we should get those 4 letters echoed back at us at the command line. So they should come back out in standard out. So it should print A, B, C, and D on 4 lines, and then on a 5th line it should echo hello world, and that should be the output for this script. So we're going to save our script, Control O to save, then hit enter, and that saves the script. Control X to exit, and then we want to execute our script. Now remember, I'm in my share directory, and in my share directory all of the files that I create are executable by the group which I'm a part of, this VBox SF group, or VirtualBox shared files group, that I'm a member of. So my script is executable, and I can check that with the ls-l-h command, and that shows me that script is executable. So the user That's the first RWX has read, write, and execute permissions. The user that owns this file is the root user, which is not me. But the group that owns this file, which is the vbox.sf group, which is also shown on this long listing format here, this vbox.sf group, of which I am a part, and we can check that in a second, also has RWX, also has read, write, and execute permissions. Just to check that I'm a part of that group, we can run the groups command, and that lists the groups of which I am a part. And we can see that vbox.sf is included in that listing. So I'm a member of that group, so therefore by virtue of that I have the permission to execute this script. Okay, if we weren't sure about that, then we could add execute permissions. We could add execute permissions with the chmod command. So we could add group execute permissions by doing g+x, and then the name of the thing that we want to do. So there you go. So that's then the code for adding execute permissions to the group. If you want to add execute permissions for the user, which would be the usual thing, because usually you would be the owner of the files that you create, and if you want to add execute permissions for yourself, for the user, to the file, then it would be u+x to add user execute permissions. Okay, so that gives us the permission to execute the file. Then in order to actually execute it, you need to tell bash exactly where it is. So we do that with the / to say it's in the current working directory, then the name of the file. We're giving this no arguments because we've removed the ability for this script to process those arguments, so it's not going to use the arguments at all. So we just run it without any arguments, and that should hopefully do what we expect. And it absolutely does. So there we go. Our loop runs 4 times and prints the contents of the I variable each time. So the I variable is set to A the first time, then B, then C, then D. And then our loop finishes because there's no more input for it to process, and the line after the loop runs, and we echo hello world after the loop has finished. Okay, so that's our first example of a for loop, which hopefully is relatively straightforward for you to understand. Anything else that we want to do with loops is essentially a kind of development of this first example, this first way of defining a loop. And we're not really going to change the way that we define the loop particularly, but we might change the inputs for it, and we might change where we get the inputs from, and that's important later. So you don't have to laboriously type out all of your inputs for your loop, although we are going to do that to begin with. But there are other ways of getting input for a loop, and I think we'll look at some of those as we move on, maybe through today, but we might look at some of them tomorrow, depending on time. So what I want to do over the next couple of days is I want to do our first bit of kind of real bioinformatics. So what I would like to do, and we'll build up to this, is we're going to write a script, and I think we'll probably do this over the course of the rest of the week. We're going to write a script which will download some sequences from Uniprot. So we've already looked at how to do that at the command line, and we've used wget to download data from Uniprot already. So we're already familiar with that process. So we're going to write our script that downloads some data from Uniprot. And I've got a list of some ACE2 some ACE2 homologs from various organisms that we can use for this. So we've already looked at the UniProt entry for human ACE2, but we're going to look at some ACE2 genes from some other organisms as well when we do this. So we're going to download some sequences from UniProt, and then we're going to use those sequences to build a multiple alignment. So we're going to use a piece of software to construct a multiple alignment for those sequences. And then hopefully by the end of the week, we should have a multiple alignment that we can look at in an alignment viewer, in a piece of software for viewing an alignment. In order to be able to do that, first of all, we're gonna write a loop that downloads the data so that we don't have to download all of that data by hand, but sort of one command, by writing one laborious command at a time. So that's the first job. Then we're going to look at the software for doing the multiple alignment, and we're going to work out how to install that software. And so that will involve talking a little bit about how we're going to manage our bioinformatics software in our Linux installation. So that's what we're going to talk about probably tomorrow, I suspect. And then we're going to include the code for running the multiple alignment in our script. And then finally, by the end of the week, we will look at a program for then viewing that multiple alignment and manipulating it and using it to try and understand some things about the proteins that we've downloaded, the sequences that we've downloaded. Okay, so that's my loose plan for this week. As much as I ever get a plan, I think that's probably a reasonable goal. So what we're going to do first then is we're going to take our script that we've developed so far, and we're going to start to change it so that we can use it. Instead of using it just to echo our variables back to us, we're going to start to change it so that it's configured to download our data from UniProt. Okay, so unfortunately for this, I've got about a dozen UniProt identifiers that we're going to define. What I'm going to do is I'm going to put those UniProt identifiers into a text file on their own, and then we can use that text file as a means of input to our program eventually. But let's start by creating that text file. So nano for that, and we will call it uniprot ids.txt. Okay, so this is just going to be one identifier per line, and this is just us getting our identifiers into one place to begin with. So the first one is the human one, which hopefully we've all committed to memory by now. I haven't, but Q9BYF1. So that's the human ACE2. The others, I'm afraid I can't remember what all the organisms are. I think the first one is gorilla, but after that, I'm afraid I get a bit more hazy. So each one of these is an ACE protein from another organism, from an organism other than human. So that's the first one, G3QWX4, and then we've got Q5 RFN, 1, then F7AH40. Next one's a 10-character identifier, so A0, A5, F4, W5, D9. So the UniProt changed their identifier system a few years ago. So it used to be everything had a six character identifier, and initially they actually all began with P and then were followed by a number. But that was never going to expand to give you enough identifiers for all of the proteins that were being added to the UniProt database. And so they changed the system to allow, initially to allow Qs as well as Ps, and then to allow letters as well as numbers in the identifier, and then they started using other letters. So you can see here we've already got one that begins with a G and one that begins with an F, and then finally we went to 10 character identifiers, because it gives you a lot more flexibility for the number of identifiers available to you. So then Q56H28 is the next one, then Q5EG Z1, Q8 R0 I0, F6 WX R7, this is G, I'm getting this 1, KTF3, E7 F9 E5. Last one you'll be glad to know, A0 A1 L8 E5 F5. There you go. So that's our 12 identifiers that we're going to do. So those are the protein sequences that we're going to download from UniProt. So what we're going to do is we're going to build up our script to enable us to use these identifiers to download that data. Okay, so first things first, let's exit, let's save those identifiers. So Control O to save, enter, Control X to exit. So that's our identifiers saved in a file. So the first thing that we want to be able to do is loop over the lines in that file. So write a for loop that doesn't just take the identifiers that we type into our script, but actually uses the contents of that file to loop. And I will confess right from the beginning, I do know ways of doing this, but I'm not necessarily sure if a way that uses the tools that we've already got at our disposal is going to work for this, but let's try it and let's see. Okay, so right, first things first, we need to edit our script. So actually what I'm going to do at this point is I'm going to copy our script again. So rather than just being a test script, this is going to be our get UniProt data.sh. So a script that we're going to, sorry, I've got to copy my test loop. So I've got to have a copy needs a source as well as a destination. So that's copying our script, and then we're going to edit our get UniProt data script. So our loop, what we want our loop to do, instead of looping over things that we type in, so we could here type in Q9BYF1 space G3 QWX4, etc. And sorry, okay, this would work fine. So save, yes, I want to save it. Okay, so then if we now execute that script, it's going to echo back those identifiers to me. So I could type those 12 identifiers into that for loop, and it would work just fine. It's not a problem. And actually, for 12 identifiers, that's not an unreasonable thing to do. But it might be that those you're getting your identifiers from somewhere other than me telling you what those 12 identifiers are. So it might be that you're running something on some sort of blast on Uniprot that gives you some identifiers that then you want to be able to download those sequences and build a multiple sequence alignment, which is not an unreasonable thing to do. So you run BLAST, you've identified some homologs, and then you want to build a multiple sequence alignment to analyze those homologs in more detail. So you might be downloading the results of your BLAST query on Uniprot, and therefore you've got your identifiers in a file because that's where it's come from. So it's not completely unreasonable to want to do this as in the way that we're going to do it now, which is to get some identifiers from your file and use them in your for loop in order to download your sequences. Okay, so we're going to go back into our script and we're going to try and figure out how to get our script to instead of looping over the things that we type into our script, we're going to try and get it to loop over the contents of the file. And so the best way to do that, the best way to do things like this is to be able to execute a command in your script, and instead of having the output of the command just go where it normally goes, so in the case of most commands that would be that it would end up getting printed to standard output, for instance, it would be nice to be able to instead capture the results of that command as a variable in our script. And we can do that with some special syntax that I will show you now. So if we want the contents of our file in a variable, then we can make use of bash. We can make use of the cat command, and we can make use of the bash syntax for capturing standard output as a variable. And this is the way that we do it. So we want to define a variable that we want to use to capture this output, and then you execute your command inside a dollar with a round bracket. So not a curly bracket that we've been using up until now, but a round bracket. And then you put your command inside the brackets. So we're going to cat our, what do we call it, uniprot ids.txt file. Okay, and so this little bit of bash syntax here says execute the command inside the round brackets and give me back the result, give me back standard output as a variable called var. Okay, so this will execute the cat command and give me back the output of cat as a variable. And just to prove that, then we can echo that variable back. So if we echo $var, this time with the curly braces, not the round brackets, then that will show me the contents of my variable. For now, I'm just going to leave the loop as it is. Okay, so let's exit this, making sure we save it when we exit, and then we're going to rerun our script. So execute it again, get uniprot data. And so you see that what we get back is the contents of the file, although the new lines seem to have gone, which is not necessarily the behavior that I expected, but that's fine, that doesn't matter too much. So you can see that that first line that's our variable called var, and that has the contents of our file in. It's just that the new lines have been replaced by spaces for, I'm afraid, reasons that are slightly beyond me at this point. I'm not entirely sure why that's happened, but I'm sure there's a very good reason for it. And then my loop has run, and so those two identifiers that have been echoed there, that's because my loop has run. But you will notice that the output of our cat, stored as a variable, looks like what we would type at the command line if we were to type out all of our identifiers. So I think my instinct is that we can use that variable in our for loop, and that will give us exactly what we want. Okay, so we're going to go back and edit the script again, and this time I'm just going to make one change, and that is that instead of my for loop, so I'm going to make two changes. I'm going to delete this echo here, Control K to delete the line, and then I'm going to change my for loop so that instead of my I being set to these two things that I define, I'm going to have I set to the contents of my var variable that I created by catting in the contents of my uniprot IDs file. Okay, so that will hopefully that will run this loop 12 times, and each time it runs, it will echo out one of my 12 identifiers, because I think that using cat in this output capture here on this line to set var has given me exactly the structure that I need to be able to then loop over the contents of that file. So I'm going to save my file and exit, and then execute my script again. And hopefully what I'll get this time is 12 lines of output. Each line will contain one of my 12 identifiers. And yay, that is what I get. So this is live bioinformatics in action. And we're gradually putting together a script that's going to achieve our goals, which is to then download each of these pieces of data. Okay, so let's finish this off as much as we can anyway. So I'm going to do this twice more. Once to include let's build these up instead of being identifiers. Let's make them into URLs, and then we'll change it one final time to add our wget statement in. Okay, so okay, let's edit our script again, and let's add the let's just move this down. Okay, let's add in the trunk of the URL as a variable. So URL equals, I'm going to put this in quotes, HTTPS, I think, //www.uniprot.org, and it's /uniprot, and then it would be, and then you would have your identifier .fasta to download the sequence, which we'll add inside the script. Okay, so that's our URL. And the reason that I've put that there is actually it doesn't save us very much typing in this instance, but it can potentially be useful for reuse, to be able to reuse this in different places in your script if need be. Okay, so we're going to stick with an echo, but we're going to echo, instead of just $i, it's going to be $URL, which is the variable that we just created, /$i, and then we're going to do .fasta. So that should be the URL of the file that we want to download. Okay, so let's test this. So again, Control O to save it with the same name, Control X to exit, and then /get uniprot data.sh. And so now, instead of printing those 12 identifiers, it should print us out 12 URLs. Okay, and indeed that is what's happened. These are transformed magically by our terminal emulator into clickable links. So if we right click and then open link, it should open a URL should open a browser for us, and that URL should open in the browser, and hopefully the browser will just show us the FASTA entry. So there you go, that's one of those bits of data. So that shows us that the URLs are valid, they're the right thing. And there's our data that we want to download. That's the sequence. Again, this time it's the human sequence. But that shows us that we've got valid URLs, and hopefully, excuse me, hopefully I've transcribed the identifiers correctly, and we've got 12 ACE genes from 12 different organisms. Let's download that data now. Okay, so this is our final change to our script for today. So we're going to go back to Nano and edit the script for one last time. Okay, and what we're going to do this time is, rather than just echoing that URL out, we're going to wget it instead. Okay, so we're going to use webget to download instead of just echoing. And I'm just going to put a couple of extra things in here just to let's put a tab rather than there we go. Sorry, don't mean to keep coughing at you. I've been talking for a long time. Right, okay, so I'm just going to put some just some little statements in here. So echo downloading UniProt entry $I, and then echo done downloading okay, just to give us some little progress markers as we go along. Okay, just to give us some output, basically. wget will actually produce quite a lot of gubbins out to standard output as well, so we're not going to be struggling to see what's going on here. So Control O to save, Control X to exit, and then /get UniProt data to execute the command. Actually, before I run it, I'm just going to show you the contents of my directory as it currently is. So we've got our test loop script, we've got our get UniProt data script, which is the one that we've been writing, and then we've got our UniProt IDs file, that file of our 12 identifiers. Okay, so away we go. We're going to do /get UniProt data, and this should run wget 12 times and download 12 FASTA files to our current working directory. Okay, so off it goes, and you can see wget doing its thing and downloading that data. It's relatively quick because these are quite small files. None of them are huge. It's not a very long protein. So it worked relatively rapidly, downloaded our 12 files, and now if I list the contents of my present working directory again with ls, you'll see that I now have, as well as the 3 files that we had before, I now have, it looks like 12 FASTA files. We can check that actually. We can check it using the tools that we've learned about so far during our 2 weeks of learning. So ls, which you can modify with an option -1 to list the results of your ls command one line at a time. So each result comes out on a single line. We just want the FASTA files. So we're going to use a wildcard, the star, which matches any character any number of times, and then .fasta to give us just the FASTA files. And then we're going to pipe the results of that into the wc command, which we did briefly cover probably in the first week, I think. And then we're going to give that an option as well, the -L option, to just count the lines. So that feeds the results of our ls command, which is our fasta files listed one line at a time, into the word count command, wc. So instead of reading a file, wc here is reading the standard input. So we're redirecting the standard output from ls into the standard input for wc, and then it's going to count the number of lines in that standard input. And bear in mind that we're putting one file that's returned by ls on each line. This will tell us how many fasta files we've downloaded. Okay, it looks like it's probably 12, but let's check, and it is 12. Okay, so our script has done what we wanted. We've downloaded the data that we wanted to download. So that is for loops, and it's also let me set out kind of my plan for the rest of this week. So what we're going to do tomorrow, I think, is we're going to start to look at installing bioinformatics software in the most straightforward way for beginners, which is to use Conda. So I'm going to introduce Conda tomorrow and talk a little bit about what Conda is and how it allows you to install software, specialist software on your system. So in our case, software for doing bioinformatics. So that's going to be tomorrow, and we will get, by virtue of using Conda, we will install a program for constructing multiple sequence alignments called Muscle. And then later on in the week, we will continue to work on this script that we've started to incorporate building that multiple sequence alignment and so on. So that's my kind of plan for the rest of this week. Bear in mind that we've got a 4-day week this week. So Friday is a public holiday. There won't be a lesson on Friday this week or a lesson on Monday next week. So we've got a 4-day week this week and a 4-day week next week. Right. Okay. I'm going to get back to my hole. For those of you that joined late, see earlier for context. And I will see you all tomorrow. And I'll make sure I set an alarm to remind me that I need to be online at 4 p.m. So I will see you all tomorrow at 4 p.m. Enjoy your evenings and tune in tomorrow. Okay, so keep safe, stay well. See you tomorrow. Bye.